Blast off. And we're recording. Let me just double check to make sure we're recording. Yep, we're good. All right, so say hi, everybody.
Hello.
Okay. Now you're YouTube famous because you're on my channel. All right, so again, to recap for the friends playing along at home, the second part of chapter 6 is all going to be about what we can do with our knowledge from the first part of chapter 6. How do we take what we know about dividing and multiplying it and turn that into how do we graph with polynomials? How can we work with these polynomials? Okay, so the section 6.4 is all about factoring. Now, recall that if a number is divided by any of its factors, then the remainder is 0, right? If I took, 35, what is one of the factors of 35? 7 or 5, right? So if I take 35 and I divide it by 7 or 5, it comes out as a nice round number, right? The remainder is 0. What happens if I take 35 and I divide it by 4? I get a decimal, right? There is some sort of remainder. If I take, 15 and I divide it by 4, there's a remainder, right? There's a remainder of 3, right? Because it's 3/4 left over. If I take 15 and I divide it by 5, what's the remainder? Nothing. It's 3 remainder 0, right? So if I take a number and I divide it by one of its factors, the remainder should be 0. Likewise, if I take a polynomial and divide it by any of its factors, the remainder is 0. If I take a polynomial and I divide it by any of its factors, the remainder should be 0. So go with me here. You know what? I'll do it on here so the video can catch it as well. I am going to make a polynomial real quick. I'm going to have x minus 2, x plus 3. I'm just making this up. So we've got x. I'm foiling this together. X squared minus 2x plus 3x minus 6. So x squared plus x minus 6, right? Say I had this polynomial, right? And I wanted to divide it by one of its factors. What is one of the factors of x squared plus x minus 6? Well, I just started with them, right? X minus 2, right? So if I took x squared plus x minus 6 and I divided it by x minus 2, what should happen with my remainder? My remainder should be 0. So take a look here. Okay, I'm going to do this the easiest way possible. Synthetic division is the easiest way because I'm dividing by a binomial. And I've got 1, 1, negative 6. Okay, so this is a 1, a 2, a 3, a 6. Hey, look at that. Right? Don't I get a remainder of 0? Okay, what if I flip that around? What if I had said x squared plus x minus 6, and I wanted to divide that by, let's check the other one. I divided it by x minus 2. Let's try x plus 3. Right? What should the remainder be? 0, right? So what number goes in the box? Negative 3. So we got a 1, a negative 6. So we got a 1, a negative 3, a negative 2, a positive 6, and we get a 0. Look at that. And look at what the result is. The result is the other factor, right? Take a look. If we divided it by x minus 2, the result is an x plus 3. If we divided it by x plus 3, the result was going to be x minus 2. Okay? So just like numbers, if we take a number and we divide it by one of our factors, the remainder is 0. If we take a polynomial and we divide it by one of the factors, the remainder should be 0. Okay? So it's an easy way to check that. That uses that remainder theorem, right? That remainder theorem. We used it for synthetic substitution, I think it was. But this remainder theorem basically states what we just talked about. That if a polynomial is divided by x minus a, so a linear binomial, the remainder is the value of the function of a. So if x minus a is a factor of p of x, then p of a must be 0, right? P of a must be 0. This basically says that the remainder must be 0. The remainder must be 0. If it's not 0, then either you did something wrong or it's not a factor. Okay? So this is going to be interesting here. Because very soon enough, we're going to we're going to be given a big long polynomial, big scary looking polynomial, and I'm going to say, okay, is this one of my factors? You have to check it, okay? And you have to check it and say, okay, yes, it is one of my factors, or no, it's not one of my factors, and then you got to move on. If it's not one of my factors, you got to try something else. And then if it's not one of the factors, you got to try something else. And if that's not one of the factors, you got to try something else. Okay? But how do you know that is it a factor? Well, if you get the remainder is 0. Okay? For any polynomial, p of x, x minus a is a factor if p of x, if and only if p of a is 0. And it's interesting to point out here that the notation is saying, spit a bunch. Sorry, I'm going to splash. I'll bring ponchos. Look at the notation. This is more like synthetic substitution rather than synthetic division, right? Because how did we interpret synthetic substitution? Well, the last number, the remainder, was just what you get when you plug it in, right? So this is interesting to point out that if you plug in that number that you put in the box, you get 0 out as well, okay? So if you run a number through, like if I had, that x squared plus x minus 6, and I said, okay, plug in 2, what do you get? 0. If I said, okay, plug in -3, what do you get? You actually end up getting 0. So when I evaluate a function for that number, you get 0, which makes sense because what are zeros of a function? What's another name for a 0 of a function? Graphically. An x-intercept, right? An x-intercept. What does an x-intercept look like? A number, comma, 0. Input 2, output 0. Input 3, -3, output 0. Those actually are the x-intercepts. So this is all tying into, how do we graph these things? We can see the long game here. These are actually where it's crossing the x-axis. And those are very important pieces of information when you go to graph. Okay. So let's try it. Let's see. Let's test out. Let's see if x plus 1 is indeed a factor of x squared minus 3x plus 1. I could try to factor x squared minus 3x. I don't know how we got x plus 1. Some method, which we'll learn about in section 6.5 and 6.6. But I don't know how we got x plus 1. We'll figure that out later. But this is just to test if x plus 1 is indeed a factor. So what goes in the box? -1 goes in the box. We got a 1, a -3, and a +1. So we bring down the 1. 1 times -1 is a -1. We got -4, +4. Uh-oh. Is x plus 1 a factor? No, x plus 1 is not a factor. This is not 0. So this is not a factor. Okay? That make sense? So it's an easy check to see if something is a factor or not. Okay, try that one. Forget how to write. That's not good. I think we will be able to use that. You're like subliminally relearning Algebra 1 as you're learning how. It's just infusing into your brain.
So much.
You're getting 2 lessons.
That's great.
Okay, what number goes in the box? 2.
Oh, I did do it right. Okay.
Now watch out, it's not 6.
Why did you change to -30? What was the reason?
What did I do now?
Oh, it wasn't on purpose? Okay.
That was to make sure that everybody was paying attention.
Right, okay. Yeah. Okay.
So, 2 goes in the box. Right? How do we know that? Because it was 3x minus 6 equals 0, right? You set it equal to 0. Add the 6, divide by 3, x equals 2. That's why the 2 goes in the box. Then we got a 3, a -6, a +6, a 3, and a -30. -30. Okay, so let's see. We've got a 3, a 6, a 0, a 0, a 6, a 12, a 15, and a 30. So is 3x minus 6 a factor of that big long polynomial? Yes. And that wasn't too hard to check that, was it? It wasn't too bad to check that. You know what's cool is that the resulting polynomial is, 3x to the third plus 0x squared plus 6x plus 15, right? And then maybe we could do something to factor that down, right? And that's what we'll do in section 6.5. Okay. Now, today is just factoring, right? Today is factoring. So let's remember the process of factoring. What should you always check? Way back in Algebra 1, what was the very first thing that you should always check? A GCF, right? GCF. KFC. Okay. The first thing you should always check is a GCF. Is there a GCF in here? No. There's no GCF in this one. Other than one. Thank you. Other than one. Right. So if there are 4 terms, what's the only thing that you know how to do?
That is true. You do know how to do it.
You do know how to do. This would be a cubic polynomial? Yeah.
4 term.
You could call it.
4 term.
Right, it's a 4 term, but it's cubic, right? Because it's x to the third. Now, what's the only thing that we know how to do with a 4 term thing? Anybody remember? Grouping. Right. The only thing that I know how to do with a 4 termed polynomial is factor by grouping. So let's try that. Because if this truly says to factor, then that's the only thing that I know how to do other than factor out a GCF. If this doesn't work, then I've got to go to some other method, which we'll learn about later. Okay, so what's my GCF of my first 2 terms? X squared, right? So that turns into an x minus 1. What's my GCF of my second 2 terms? 25. Let's pull out a negative because it leads with a negative, which means that it's an x minus 1 inside parentheses. And hey, look at that. This factor. And what's cool about this is that, so this is an x minus 1 and an x squared minus 25. Am I done? No. That's a difference of squares. So we've got an x minus 1 and then an x minus 5x plus 5. Again, we can see where this is going. Graphically, where do you think my zeros are at? 1, 5, and -5, right? This will cross the x-axis at those 3 spots. Let's keep it going. Why don't you guys try that one? Okay, so let's factor by grouping. Well, I guess I should first say, is there any GCF of this entire thing? No. Is there any GFC? No.
Any KFC?
I
kind of want some fried chicken now. I gotta be. We were driving. This is okay. I might have to cut this out. But we were driving by we were at Target yesterday morning, and right.
Yeah.
Well, actually, even cider story. My 3-year-old Sadie, she slept without her pacifier for the first time this past week. So we had to make it a big deal. We had to go get some presents for her. You know, the Passy Princess didn't come yet to take it away from her, but it's, you know, she did not sleep with it. She was so proud of herself. Anyway, so we were at Target yesterday morning getting all that stuff. And we obviously it's Sunday. Everybody like craves Chick-fil-A on a Sunday, but it's not open. So we went to Cane's and we got chicken. And we were driving home and we passed KFC and we're like, okay, with Chick-fil-A and Cane's right there, how does KFC stay open?
Yeah, that's true.
You know, like how does anyone go to KFC? I get like in Hartville, there's not more options. But how does KFC stay open?
13 spices.
Who goes to KFC?
Everyone was hoping to see that good old Colonel Sanders. I mean, what a
Which is
man.
weird.
You know, and then because I said, well, in Hartville, like, there's no other fried chicken. Laura, and my wife was like, I would go and get it at the kitchen. Like, I would just go to Hartville Kitchen and get fried chicken from there. I was like, well, you gotta wait that long. She was
Yeah.
like, worth it.
Some people just like 13 ounces of spices though. They have
I know, it's like, put the mashed potatoes and the cheese and the corn and the bowl and the chicken. And let's just get an IV of cholesterol right away. Okay, sorry. Okay, and we're back. And action. All right. So we've got a 2x plus 1. And then what do we pull out here? A 4, positive 4, to get a 2x plus 1. Now, this gives me an x squared plus 4, things on the outside, things on the inside, 2x plus 1. Can I keep going? No,
It's not minus.
because it's not a minus.
Got him.
Gotcha.
I know. That's good.
I wish we were like actually recording this.
Yeah.
Just recording our voice for
Like video. I could do the webcam. Like, I could embed the webcam.
I feel like
Guess
our
I could.
expressions are pretty iconic. So.
You need to get
All right. Okay, questions on that one. Sorry, I flipped the page. Questions on that one. We good? We all know why that it doesn't factor even further because of the plus sign in between here, not a minus. Okay. Now, actually, let's think about this. Where would the zeros lie? Where would this 0 lie? Negative 1/2, right? Because I would have to subtract the 1 divided by 2. Where would these zeros be? What would happen if I did this? I would get this. So would there be any real zeros that are associated with this? No. This is gonna get fun by the end of the chapter. All right.
They don't.
It's too early for this.
The last type of factoring that you will probably learn. Yeah, the last rule of factoring that you'll probably learn is factoring sum and difference of 2 cubes. Okay, you've done difference of squares, so let's talk about difference of cubes. What's cool about cubes is that you can actually do sum of cubes. You can do an addition of 2 cubes. You can factor that down. Where we could not factor down x squared plus 4, you could factor down x to the 3rd plus 8 because they're both perfect cubes. How do you know a perfect cube? Well, any perfect cube is, in terms of a variable, the power is divisible by 3. Okay? Any perfect square, the power is divisible by 2. Any perfect cube, the power is divisible by 3. And then you should start to recognize perfect cubes in terms of their number. Like 1 to the 3rd is 1, 2 to the 3rd is 8, 3 to the 3rd is 27, 4 to the 3rd, that would be 64, 5 to the 3rd would be 125, and that's where my memory starts to go. I think 216, 6 to the 3rd. Let's see that. 6 to the 3rd, is that right? Yeah, 216, I can't remember. 7 to the 3rd, I'll just do that. There you go. 343, 8 to the 3rd, 512, 9 to the 3rd, you know, and then what would be 10 to the 3rd? 1,000, right? 3 zeros. So not necessarily saying that you should memorize those things. I'm just saying that these cubes come up a lot. especially when working with these things. Okay. Now, how do you factor them? Okay. Go ahead and write that down, and I'll explain it here in a second.
A lot of script. Crazy, yo.
It's all letters. Yeah, it's okay. No. Okay.
What about this conversation? What about this conversation?
No, I want YouTube to know how we live our lives.
How many subscribers do you have?
I think I'm up to like 2 million.
Oh, yeah. I was one of the first
So he's
50.
monetized right now.
I'll do it in to Texas. No, I came before him. He's the next.
Oh man.
You don't have a name like Bird.
I think I'm.
He doesn't have a name like Labyrinth.
Who?
God,
Throw down.
like, oh.
Good job.
Not only
Con?
videos.
No, that's it.
Yeah.
So
No,
Edward Bergen.
I'll make up my own video factor. I'm gonna call it
The greatest factor time is.
elaborate.
Difference of elaborate.
Difference of elaborate polynomials.
All right. So here's how we factor sum and difference of cubes. Okay. So first of all, they have to be cubes. They have to be perfect cubes. So like what we're showing here is two terms that are something raised to the third power, right? Like 8 is also 2 to the third. Right? So 2 would be the cube root of 8. X to the 9th would be a perfect cube because that's x to the third times x to the third times x to the third because we add those exponents up. So you take the cube root of each term, and then here's what you do. You take a, then b, a squared, product, b squared. And that's the same here. The only thing different is that the signs will change. Okay, so factoring a sum or difference of cubes gets you a binomial and a trinomial. The binomial is just the two cube roots, a and b. The trinomial is a squared product b squared. A squared product b squared. So what's going on with the signs? Well, my Algebra 2 teacher taught me a rule. He always said, Mr. Rigler, shout out Mr. Rigler. He always said when factoring sum or difference of cubes, you keep it clean. You have to use soap. Okay, you have to use soap whenever you're doing these things.
It's gonna be it.
So we just like chug some soap while we do this.
Okay, this is the same sign. This is the opposite sign, and this one is always positive. This is the same sign, this is the opposite sign, and this is always positive. What does that mean? It was a minus, right? In the second example, it was a minus. So it's the same one, it's a minus sign. This is the opposite, so it's a plus sign, and this one is just always positive. Okay? For a plus, for a sum of cubes, this is the same sign, a plus, this is the opposite, a minus, and this one's always positive. I don't know, that just stuck in my brain. You could just memorize it, whatever. Same, opposite, always positive. Same, opposite, always positive. Okay, let's try one, shall we?
I don't like that.
First of all, I see some issues with this. Is 4 a perfect cube? No. Is x to the 4th a perfect cube? No, it's not. 4 is not divisible by 3. But what did I forget to do at the very beginning? A GCF. So let's see, maybe 108 is divisible by 4.
Of course it is.
Hey, look at that. So it's 4x as my GCF, and then since I removed that, it's an x to the 3rd plus 27. Is x to the 3rd a perfect cube? Yes. Is 27 a perfect cube? Yes. So now what we can do, let's just bring down our 4x. we get a binomial and a trinomial. I like to put my addition or subtraction signs in right now. Okay, so this is the same, this is the opposite, and this one's always positive. My binomial is just the two cube roots. Well, the cube root of x to the third is just x. The cube root of 27 is 3. 3 times 3 times 3. Okay, and now I do squared, product, squared. And that's how we factor that down. Your trinomial will always be fully factored down. You could check, okay, factors of 9 that add to get to -3, but there are none. That's going to be common throughout. You're not going to be able to factor down that trinomial. Okay. Questions about that? Soap. Keep it clean. Use soap. Okay. Let's do this one. 125d to the third minus 8. 125d to the third minus 8. Now, I don't know. Let's check to see if 125 is divisible by 8. Nope. So no GCF.
How dare you?
No GCF. So let's see. Is 125 a perfect cube? Now here's how to check. You go into math. Just a second. Hit math, and then the cube root button is right here. So 125. Yeah, it is. D to the third. That's a power divisible by 3, and then 8. Obviously a perfect cube. 2 to the third. Okay, so we have a binomial and a trinomial. Same, opposite, always positive. Cube root of 125d to the third is 5d. Cube root of 8 is 2. I square 5d, it's 25d squared. Don't forget to square the 5 as well. I find the product of 5d and 2, which makes it 10d, and then I square 2 to make it 4. That make sense? Okay. Let's try one more of these. Is this in standard form? No, let's put it in standard form to start out. So let's say z to the 6th, let's put it like this, plus 8. Okay, is z to the 6th a perfect cube? Yes, because the power is divisible by 3. Z to the 6th is like saying z squared times z squared times z squared, right? So the cube root of z to the 6th is z squared. The cube root of 8, obviously 2. So we have a z squared plus 2. And then we have a, okay, z squared squared is z to the 4th. I forgot to put in my sign. Same, opposite, always positive. Sorry about that. And then we have the product 2z squared. And then we square the 2 to get 4. Questions about that? Feel good about that? Okay. Let's take a look here. Last question. I literally just added this problem about an hour ago. 7:15. Yep. So hopefully this works out, right? This is the first time I've ever done this problem. Okay. There's the reason we're doing this is because there's one like this in the homework, and usually you guys get confused about it, so I added this into it. All right. It says use the graph to factor the polynomial. What? Using a graph to factor? What? Now, if I want to factor the polynomial, I need one of the roots of the polynomial, right? I need a 0 that I can easily see. What's one of the zeros that I can easily see? Is that one good? No. Is this one, well, kind of, no. But I do have a 1, a 2, a 3. Yeah, that's crossing nicely at a 3. Now, if this were graphed in my calculator, I could go to my table to see that, yes, indeed, it comes at 3. But if you had your calculator, you could just calculate those zeros anyway. So let's try not to do that, okay? So let's say we think that x equals 3 is a root, right? We think that x equals 3 is a root. How can we know for sure if x equals 3 is a root? Plug it in. Synthetically divide. 3's in the box. We got a 4, a 0, a negative 43, and a 21. Let's see. We've got a 4, a 12, a 12, a 36, and a negative 7, and a negative 21. Is x minus 3, you see what I did there? Is x minus 3 a factor? Yes, because the remainder is 0. Okay, well, what does it factor into? 4x squared plus 12x minus 7. And do we all see how this relates? Do we all see how it changed into a minus? Because the number in the box was a positive 3, so that the corresponding factor, the corresponding binomial, is an x minus 3. And now, let's try to factor down this to see where these actually are. Okay? I mean, if I can't factor this down, then I would stop. Let's see if I could actually factor this down, though. Let's find, so this is a hard type factoring. Let's find the factors in negative 28, right? 4 times 7, negative 7, obviously. What are the factors in negative 28 that add to get to positive 12? 14 and negative 2. Negative 2 times 14. So this does indeed factor even more, right? So let's keep it going. I'm just going to work with this. I'll just bring down my x minus 3, save for later. So we got a 4x squared minus 2x plus 14x minus 7. And we factor by grouping. We pull out a 2x, leaving a 2x minus 1. We'll pull out a 7, leaving a 2x minus 1. So this fully factored down is 2x plus 7, 2x minus 1. So we just successfully factored down this trinomial that we had no idea how to factor before, right? The only thing we knew how to do with a trinomial, it had to start with an x squared. If it didn't have 4 terms, we couldn't do it. So we successfully factored down this trinomial just by looking at its graph. That's pretty cool. That's how we factor it down. So where did these zeros end up being? Well, 2x plus 7 equals 0. Subtract the 7, divide by 2. Negative 3.5. And add the 1, divide by 2. 1/2. Makes sense. Good to go? Homework is over there on the board, page 433, 16 to 36 students. Say bye, everybody.
Don't forget to like and subscribe.